Hello folks, we are back with the next video for this cos x. See, the next question is question number 12, where they ask us, they give us different functions and they give us the interval 0 to pi by 2. And they are telling us that on this interval 0 to pi by 2, the different functions which are given, you have to check whether which of the following are decreasing. Whether it is decreasing or not, that we have to check. So that's going to be our work. The very first function that they give us is cos x, and we have to show whether cos x is decreasing or not on this interval 0 to pi by 2. That's our work. So let's see, decreasing we know. Anyhow, we have to take the derivative. That's going to be an inevitable step. So let's take the derivative, and then from there let's find out what can be done. So first let's call this as f of x. Let f of x be this cos x. So let's find the derivative, f dash x. Cos x, we all know the derivative is minus sin x. Now, sin x, we all know that between 0 to pi by 2, sin x value is always positive. Like we know, no? We can take any value. You can take sin 0 is 0, sin maybe 30 degrees, sin 45 degrees, sin 90 degrees, sin 60 degree, etc. They're all positive. So between 0 to pi by 2, sin values are positive. Obviously, minus sin x, therefore, is going to be negative. So that's very clear to us. So we can maybe analyze that here. Between when x is between 0 and pi by 2, the sin x is also between 0 and 1. Sin 0 is 0 and sin pi by 2 is 1. So all values between 0 and 1 happens to sin x. So that way f dash x becomes negative in 0 to pi by 2. Why? Because this value is positive. So now it's going to be negative. So because f dash x is negative in the interval 0 to pi by 2, so obviously it's going to be decreasing. So therefore cos x is decreasing. That's what they ask us, whether it is decreasing or not. Yes, so we analyze and we find out that it is decreasing. That way we have different subparts. Now the next subpart, that is b subpart, tells that you have to find out the same thing for cos 2x. So let's look at cos 2x. So let our fx here becomes cos 2x. Just like before, f dash x becomes minus 2 sin 2x. Same way, we have to check whether this f dash x is whether it is positive or negative. Then we can decide whether it is decreasing or increasing. Now here we'll just check, like if we are looking at values between 0, x is between 0 and pi by 2 that they have told us, but we are working with sin 2x. So what will happen to 2x? Where will 2x lie? 2x will lie between 0 and pi. So sin 2x, actually they are taking values between 0 and pi. That means in the first quadrant and in the second quadrant. And in the first quadrant and in the second quadrant, sin is always positive. So therefore this is going to be a positive value for us. So 0 to less than 2x less than 2 pi. Now sin 2x, if we are looking out in this interval, is a positive value. In or you can say for 2x belonging to 0 to pi. If 2x is between 0 to pi, then sin 2x is always positive. Then in that case, f dash x is definitely less than 0, because it's a positive part and there is a negative sign here. So that is less than 0. If it is less than 0, then automatically we are in a decreasing function. So we can say that therefore cos 2x is decreasing on 0 to pi by 2. That's how it is. Okay, it continues. You have the third subpart, which says that it is cos 3x. Same way, the third subpart, which says that it is cos 3x. Same story. F dash x becomes minus 3 sin 3x. Now let's see how the domain is varying. Since we have 0 less than x less than pi by 2. So what happens to 3? 0 less than 3x less than 3 pi by 2. That means our 3x takes values from 0 till the third quadrant, first quadrant, second quadrant, third quadrant. Now here sign is going to create trouble, though we've got sign here. From first and second quadrant, sign is always positive, but in the third quadrant, sign is negative. So you have partially positive values, you have partially negative values. So in this interval, you cannot tell whether it is, like, we can analyze that, no? Here, for example, let's take f dash at something in the second quadrant, no? Say 120 degree, 2 pi by 3. 120 degrees, 2 pi by 3. What happens? It is minus 3 sine 3 into 2 pi by 3. Sine 2 pi is 0. No, that's not of much good. Can we take 3 pi by 4? Yeah, why? Because it's like it gives 0, no, we'll not be able to decide. So just for you to realize, that some values are positive and some values are negative. So in the second quadrant, there is another point 3 pi by 4, which is 135 degree. Let's take this, how this behaves. So that by formula, it's minus 3 sine 3 into 3 pi by 4, which is 9 pi by 4. Now we all know that 9 pi by 4, we can write it as 8 pi plus pi by 4. Yeah, we always do that, isn't it? So that way this will come to minus sine 8 pi. When we organize, it is 2 pi plus pi by 4. Yeah, when we organize the terms, this is good old days. So this is now of the type 2 pi plus theta, which is in the first quadrant. Anything that is of the type 2 pi plus theta is falling in the first quadrant. First quadrant, everything is positive. So your answer is minus 3 sine pi by 4. Now, this is a positive quantity, 1 by root 2. So overall, this is a negative quantity. So therefore, f dash at 3 pi by 4 is a negative quantity. What we are doing is, between 0 to 3 pi by 2, we are trying to show that some values are positive and some values are negative. So it is neither increasing nor decreasing there. That's what we are trying to show. And for that, we have shown one value negative. Obviously, we are going to take some other value which is going to be positive. So let's take that. Let's take f dash maybe at 5 pi by 4. Actually, it's in the third quadrant. So let's check how this comes. Minus 3 sine 3 into 5 pi by 4, which is 15 pi by 4. So 15 pi by 4 means you can write it as 16 pi minus pi by 4. Or rather, you could write it as 4 pi minus pi by 4. Now 4 pi minus pi by 4 means it lies in the fourth quadrant, right? So fourth quadrant, sign, it's a quadrant for cos and sec. So sign will be negative. So this will work out as minus sine pi by 4. Minus and minus will be positive. So you'll get 3 sine pi by 4, which is 1 by root 2, which is positive. Right. So in this interval itself, that is between, we were looking at interval between 0 to 3 pi by 2, where our 3x was belonging. Our 3x was belonging here. We have got two values, you've got two values here. One is 3 pi by 4 and the other one is 5 pi by 4. At 3 pi by 4, the function's value is decreasing, and at 5 pi by 4, the function's value is increasing. So that's not allowed. In that interval, if you have some values decreasing and some values increasing, we can't call it either increasing nor decreasing. So because of this, we'll say that therefore, what's that? Cos 3x is neither increasing nor decreasing here. Yeah, that's for our part C. So also we can move for a part D, where they give us tan x and they ask us to check what is tan x value. So let's see now how that is tan x. So that is D now, tan x, right? So same step, we'll try to find out f dash x. So let's see, f dash x for tan x, we all know it is sec squared x. Now x is belonging to 0 to 2 pi, sorry 0 to pi, 0 to pi by 2, x belongs to 0 to pi by 2, that's what is being told to us. Obviously 0 to pi by 2 means first quadrant. In the first quadrant, sec is always positive, right? Nothing much to think about. So f dash x is positive for x belonging to 0 to pi by 2. If that is the case, it cannot be decreasing. Question is about decreasing. So you can say that therefore tan x is not decreasing. They have asked us decreasing. Not decreasing on 0 to pi by 2. On in, little confusing. Yeah, that's all. So we have analyzed all the four what's up parts and see how they are, like which is which. That's what we have done now. So that's all for this video. With more problems we come in the next video. Please don't forget to subscribe the channel. Please popularize it amongst your friends, and let's work together and grow together. Thank you.